assignment is an extension of yesterday's assignment. I'm sick. Yes. No, no, I'm just practicing my deep voice. Okay, so before we get started, I want to ask if I had, oh, I don't know, 36 over 42, does that simplify? Yes, into 6/7. Is there any difference mathematically between 36 over 42 and 6/7? No. If you divide those out, you get the same decimal. They're totally equivalent in every way. So if you look at number 1 of yesterday's assignment, you see negative 36x to the third over 42x squared. And that's simplified to be negative 6x over 7. Is there any difference between negative 36x to the third and 42x squared? No? Well, let's check it out. So, open up your calculators. I want you to graph negative 6x over 7. So, negative 6x over 7. So, I push enter, and I'm going to graph it. Okay. So, everybody graph that. And I'm going to graph the original, and we'll compare the two. So I'm going to go in, and I'm going to change mine to negative 36x to the third. And how do you divide by more than one number? How do I divide by 42x squared instead of just 42? I'm going to put parentheses around it. So divided by 42x squared. Okay, compare your graph to mine. What do you notice? Exact same. Well, everybody go into their table. Second graph. Are your tables identical to mine? Mine has a glaring difference. What does yours say at 0? Yours says 0, 0. Mine says 0 error. Why? There is a hole at 0. So in your graph, if I make a table, x, y, can I plug in 0? I plug in 0, 6 times 0 is 0, negative 0 is still 0, divided by 7, 0. In my equation, can I put a 0 right there? No, why not? 42 times 0 is 0, and you can't divide by 0 because it's infinity. Okay, so when I simplified from here to here, all I did was plug the hole. So the graph, so this, you're going to graph this on your other page. The graph comes down like this, and there's a hole at 0, 0, and then it keeps going. Only the original equation will show the hole. The simplified equation won't. And essentially what happens is, anytime you perform algebra and you eliminate a variable, when you delete a power, you end up plugging holes, basically. So this had a hole at x equals 0, and you look at my graph, can you see the hole? No. These calculators are not very precise, but if I type in, so I go trace negative 2, yes, it has an answer, negative 1, yes, it has an answer, but if I type in 0, it doesn't give me a number, it just says blank. Yours is going to say 0 because you graphed the simplified equation. So whenever you delete an x, you end up plugging a hole. Okay? So if we look at number 2, this simplifies down to 1 over r. Okay? Did we delete any x's? or r's, I guess. Did we delete any r's? Yes. But r is not allowed to be 0. In this case, there should be a hole at 0 because we deleted an r, but there's still an r in its place. And let's look and see what that graph looks like. So we go in here, 1 divided by x. Graph. And that's kind of hard to see, but this is what's going on. We have a graph that looks like this, and we have a graph that looks like that. Did I plug any holes by getting rid of that r? No, there's no hole to plug because we have this vertical line. Do you remember what those are called? A line that a graph approaches but never reaches? An asymptote. So in this case, r equals 0 is not a hole. It's an asymptote. So, if a factor cancels, the root associated with that factor is a hole. If a factor in the denominator does not cancel, then that factor represents an asymptote. What if you have two identical factors, one of them cancels and the other doesn't, which means there's a hole and an asymptote? Who wins? An asymptote, because any factor remaining will always create an asymptote. You got this. Okay. So, look at number 7. So for number 7, we have 2 times r minus 2 over r minus 2. Is there a number you're not allowed to plug into the denominator? 2. Essentially, we're asking, what is the root associated with that? R equals 2. But that 2 cancels. If it cancels, then it's represented by what on the graph? A hole. So this graph and the graph of y equals 2 are exactly the same, except this has a plugged hole and this one does not. So, should I bother graphing this difficult version? No. Am I going to see the hole on this difficult version? You're not going to see it. You could look for it and find it, but we already know where it is. So graph this and stick a hole where r equals 2. So if I go on here, I'm going to graph y equals 2. Push graph, it's going to be a straight line. And then I go along, and at 2, I put a hole like that. So the instructions say, state where the holes are, state where the asymptotes are, and then graph the equation. Okay? So look at number 9. On bottom, we ended up with 3x times x minus 4. Did anything cancel? The x minus 4's cancel. So, is there a hole? What are the roots here and here? X equals 0 and 4. So this graph, every x value shows up on the graph, so the domain is all real numbers except for 0 and 4. Well, why isn't 4 there? What happens at 4 that prevents us? I mean, if we look on the graph, is it going to be an asymptote or is it going to be a hole? Well, if the factor cancels, then this root is a hole. So we write there is a hole at x equals 4. If the factor does not cancel, then that will be represented on the graph as an asymptote at x equals 0. Now, should I graph the difficult version or should I graph 1 over 3x? They're going to look the same, The only difference is 1 over 3x has a plugged hole. But we know where the hole is, so don't bother with the difficult one. But you have to make sure you use parentheses correctly. So 1 divided by parenthesis 3x. So I should see an asymptote at 0, and then I can't see the hole. Now, you can zoom in further if you want to see what that shape is exactly. But it looks like this. But over here at 1, 2, 3, 4, I need to write a hole. Is this kind of making sense? A little bit? So you need to remember, if a factor in the denominator cancels, it makes a hole. If a factor in the denominator doesn't cancel, then it makes an asymptote. What about the numerator? Well, the factors in the numerator will change the shape of the graph, and we'll just allow your calculator to figure that out for you. There's more we could go into to figure out what they look like, but not today. Another day. Okay, number 11. In the denominator, I have v minus 5 and v minus 5, and that cancels. So what two numbers is the denominator not allowed to be? 5 and? So this one gives me v equals 5, and this one gives me v equals 5. It's the same number. So if one of them cancels, does that mean I have a hole or an asymptote or both? Well, anything that stays behind creates an asymptote. You know this. It's got to be an asymptote. So I'm going to graph 1 over v minus 5, and I know that that graph will have an asymptote at v equals 5. And again, you need to use parentheses. 1 over x minus 5. Graph it. I should see a vertical asymptote at x equals 5. There it is. So I'm going to draw the vertical asymptote at 5. Oops, that's 6, but whatever. And it's going to look like this and like that. Okay. Turn the page. I don't know why on your assignment there are two... no, there aren't. They lied to me. Never mind. My last class didn't know what they were talking about. Forget I said anything. Okay, let's do number 15. Fifteen factors into x plus 2 and x plus 6 and x plus 6 and x minus 5. Nope. X minus 3. Sorry. So I know x is not allowed to be negative 6 and 3. But the x plus 6's cancel, so x equals negative 6 is going to be represented by a hole, and the x equals 3 will be represented by an asymptote. So I need to write hole at x equals negative 6 and an asymptote at x equals 3. And all I have to graph is x plus 2 over x plus 3, x minus 3. And you need parentheses both on the top and the bottom here. So x plus 2 divided by x minus 3. This one's going to look a little bit strange. So normally the horizontal asymptotes have been at 0, but for some reason this one's a little bit higher. We'll get into that later, but not today. So I know there is an asymptote at 3. And then I know at x equals negative 6, there's going to be a hole, and it looks like that hole is about right there. Oops, that's a little... This should be a... Oh! Watch this. Watch how good I am. So this piece is actually a little bit higher. It never actually gets close to the x-axis. Okay. Sometimes you'll run into something a little bit more difficult, like number 21. So on top, we pull out a 6v squared, and we're left with v plus 7. And on bottom, we pull out a 2, and that gives me a 13 and a 41. Are there factors of 41 that add to be 13? Oh, 42. That makes more sense. Are there factors of 42 that add to be 13? 6 and 7. So v plus 6 and v plus 7. So this cancels. And I know that v is not allowed to be negative 6, and v is not allowed to be negative 7. But negative 7 is a whole. So this is a whole. And this is an asymptote. But when I graph this, and I'm going to times that back in, because it makes it easier to graph, 2v plus 12. Oh, hey, even better. Let's pull out that 2. So 3v squared over v plus 6. You should be teaching. I don't know what I'm doing. So I'm going to go in 3x squared divided by x plus 6. I'm going to graph it. I can't really tell what's going on. There should be an asymptote at negative 6, right? But I don't see it. So what I need to see is more y values. So I'm going to go into my window, and I'm going to change my y window, let's say, from negative 50 to 50. See if I get a little bit better picture of what's going on. Not really, because it appears as though there's nothing happening over here on the left side, but that we know that has to be true. Somewhere there's a hole at negative 7, and there's also an asymptote at negative 6. So I'm going to go into my window, and I'm going to zoom out a little bit more. So maybe 100 and negative 100. Ah, there I see it. So this is what's going on. I do have an asymptote over here. And then this piece is coming in like this. And there's got to be a hole at negative 7. And then it's dropping off. And then this piece is coming down. And then it looks like that. So eventually, on some of these problems, you're going to have to change your Y windows until you can see the whole graph. Because it's going to be defined everywhere except at the holes in the asymptote. So if you see a big blank section, just keep looking up or looking down until you see the graph, because it's going to be there eventually. And especially where, well, never mind. We'll get into that later. So your assignment today is to graph all of the graphs from yesterday's simplification. Now, I don't have the graphs, a solution for that, but I will put up the solutions to yesterday's simplification. All right? Good luck.